Okay, so today we're doing closed-end air columns, where yesterday we did open-end air columns, and the difference is we still have nodes and antinodes. It's still a review, and each consecutive node is still separated by 1/2 wavelength. Remember, this was node and antinode. However, this is what our standing waves look like. At a closed-end air column, there is a node at the end and an antinode at the other end. So it looks like this. And the other side of the standing wave looks like that. So what is this distance here? If we have the distance between a node and if we have the distance between a node, we have these two distances here between a node and an antinode. If we establish that the distance between consecutive nodes is 1/2 a lambda, then how long is it between a node and an antinode? Okay. It's going to be 1/2 of lambda, right? So that actually means that it's going to be 1/4 lambda. That this right here is 1/4 of the wavelength of the whole wave, because the whole thing is going to go out. Or actually, in blue would look like this, and that's 1/2 the wave, and then it's going to go out and finish like that, right? So so in a standing column, if we have a closed end, then it's just going to be this is 1/4 of the wavelength. Yeah? Yeah. All right. So we just have to do all of our adjustment here. So instead of our length being the length of our the length of our column being 1/2 of the wavelength, the length of our column is now 1/4 of the wavelength, and that means that the wavelength is 4 times the length. All right. So our third harmonic, because they don't have second harmonics, we don't have this. We don't have a node here. So what we have to do is down and up again, and we have another okay. And this, I'm sorry, that's not the fifth. So red goes up and back down, and blue is going to go down and back up, and this is now 1. Okay, this is now our third harmonic, because we have 1, 2, 1, 2, 3, which is 3 times this frequency, right? So this length is now 3/4 of the wavelength and 4/3 of the length. All right. So what do you think is next? If this is 1 for the first harmonic, and this is 1/4 for the first harmonic, and 3/4 for the third harmonic, what do you think this one's going to be? 5/4 for that, and this is going to be 4/5 for the length. Okay, and that's the basis for what happens the rest of the way. All right. So like if we have a fifth harmonic in the air column whose third harmonic is 984, then this is, the fifth harmonic is going to be 984 times 5 divided by 3 for that fifth harmonic, right? So we want to find the fundamentals, so we divide by 3. Then we multiply by 5 to find the fifth harmonic, and that's 984 times 5 divided by 3. That's going to give us 1640 hertz for that one. Okay, so that's pretty much it for yeah, that's pretty much it for this, because I want you guys to be able to figure out the rest on your own and work through those. Remember that each one of these is each distance from a node to an antinode is 1/4 of the quarter of the wavelength. All right, that's all.